Greetings, friends. Today we are going to talk about data engineering, and we all will try and understand data engineering in a very, very simple and convenient manner. The other name for the data engineers is data plumbers. So, in today's world, we are talking about the modern technology and the tools that we are going to use to ensure that the data movement is happening effectively from source to destination. We all know, right? There will be some source. Data originates at the source, and these sources could be of diverse type. For example, databases are one of the data sources. APIs, which basically fetch the data from different applications. The IoT devices are also data sources. As data engineers, the primary goal is to move this data effectively for various activities, like for analytical purposes or operational purposes, etc. And that too at a scale of production level. If I talk about today's data engineers, they become the primary uh, touch point or primary resource which make the entire digital transformation for the organization possible. They become the backbone of the entire data driven economy that we are talking about today. And this is one of the reasons why data engineers are in a very, very huge demand in today's market. Let us try and move on to understand what exactly data engineers do. In its simple form, data engineers will move data from a source to destination. Okay, that's very simply put. We are talking about a source and we move the data to destination. Okay, so that's how it has to happen. And this entire process can be explained as a data pipeline. Just like how water flows in a pipeline, data is also um, analogous to move just like water. From source to destination, the data has to move in a direction. At a very high level, the data pipelining that we are talking about, the process of moving data, can be explained in this four steps. These are very, very high level steps. Of course, there are 8 different stages that we will have to understand when we deep dive into the data architectural flows. The first step here is data ingestion, which basically speaks about collecting the raw data and that too from various sources. It's not just from one data source. We will have different sources where the data which is getting collected from the organization transactions or activities have to be fetched. Now, once this data comes in, we will have to ensure that there is an appropriate form for that data. So we will have to do various transformations on the data. This ensures that the data is in appropriate format, which allows us to perform analysis in a much effective manner. This entire data that we are fetching has to be stored in a specific location. This can be your destination. Okay, here there are different type of destination that we again have to look at depending on the business requirements and business activities. Now, once the data is accumulated, we can perform different type of analysis on that particular data, which basically allows us to get the value out of that data. This entire process has to be automated, and that is one of the primary jobs of data engineers. So the movement of data from source to destination has to be automated. And again, hypothetical numbers, 70 to 75% of the enterprises are focusing and implementing this today. And their success rate is the evidence of the importance of data engineers in today's world. When we talk about sources, we have to understand that data comes in different formats, which broadly are categorized into structured and unstructured formats. Again, these are hypothetical numbers just to give you the kind of impact to understand which format of the data is generated more in today's date. So you only see 35% of the enterprise data, which is in a structured format in tables of various databases that we speak about today. RDBMS or NoSQL databases, right, etc. There are many different type of databases. The APIs, the CRMs, all these are containing structured data, which basically means table kind of a data. Data is organized. But majority of the data, which is of course close to the double the size of structured data, comes in unstructured format, whether it is system logs, social media data, or various documents, etc. A lot of this is in unstructured format. Now, this data is as important as this data. And we need to ensure we integrate all these different data sources to ensure that the data collected from all these diversified sources can be transformed into an appropriate format and stored in a single destination, single point of location. There will be a lot of challenges which can be very, very complex to solve, but data engineers are basically equipped with tools and technology to handle those challenges. Some of the common challenges are the size of the data could be very huge. The system limitations, the hardware and the software that the organizations are using, there would be some restrictions. And one of the important aspect is the quality of the data that we are handling. As a data engineer, we need to handle these kind of challenges and ensure the right quality data in its right format or appropriate format is made available for various other stakeholders. When we talk about the data coming from these different sources, it has to be integrated and has to be transformed to ensure that the entire data has some kind of consistency. This basically is categorized as transformations or data handling steps where you can do validations, you can do enrichment, cleansing, normalization, etc. Now, if we can optimize this process and ensure that the data transformations are happening faster, right? Then at the end, when the data consumers try to use the data, their life becomes very easy. All right. So that's very, very important step as part of the data engineering role. And at the end of all this, we have destinations. Data is coming from different sources. We try to pull that data, transform it, and store it somewhere. Now, in the destinations, broadly again, there are two type of destinations that you need to be aware of. One is called as data warehouses. You can just imagine this as a large scale database softwares only. In its very simple terms, okay? Large scale databases only. They are specifically designed to handle structured data and they are used for analytical and reporting purposes. But the modern day data solutions deal with AI ML implementations as well, and that too on unstructured data. So, data lakes come in handy here. They are specifically required for handling data which is in different types, right? Different formats. And the advantage is you can have massive value volumes of data in data lakes. The cost associated with data warehouses and data lakes, if we compare, data lakes are much, much, much cost effective. There can also be some kind of specialized databases to handle data like time series or graph kind of data or document stores, etc. These are specifically required in certain business cases. And finally, we will have AI/ML workflows, which, as I mentioned, will help us to generate value of the data. This helps in decision making. AI/ML workflows will help organizations to be more innovative as well. So that's it. The data engineer's role in a very, very simple manner. I am going to once again repeat it. A data engineer would move data from one location to another location. Source to destination. I'll write source here and this is destination. And in the transit, we will ensure that transformations are happening. So, hope you understand what exactly is the roles and responsibility of data engineer in today's modern day digital world. I'll try to come up with such videos explaining the role of a data engineer on day-to-day basis, the tools and technology that data engineers in today's world are using. See you in the next video. Thank you.